Okay. Hello guys. Today I will be explaining the work I've done in advanced RAG architecture and optimization. So let me go to the top. Yep. In this application, we will be evaluating three different RAG architectures, one being the basic RAG architecture and the other two being the state-of-the-art architectures. First is a simple RAG and the next one is corrective RAG, where you're adding document relevance assessment and fallback mechanisms. And then the third one is adaptive RAG, implementing dynamic query routing based on query classification. So basically, we need a RAG so that we can augment an LLM by providing it with an additional layer of access to data apart from whatever data it's been trained on. This image shows us all the different techniques we can use to optimize a RAG, and I've chosen the agentic RAG architecture to optimize it. So in this library, in this code base, I've used LangGraph for creating the agentic architecture, and I've used Ragas library for evaluating it. So these are all the information about RAG. And so first, a simple RAG where we take all our documents, we chunk it, index it, and store it in a vector database. When we ask a question, we retrieve relevant documents and then put it in the context window, that is, append our query with the additional data and then give it to the LLM for answering. Next is our corrective RAG, where we have a architecture where we take our question, give it to a retrieve node, and then whatever it retrieves from our vector database, it grades it, and if it finds like any document that is irrelevant, it rewrites the query and then does a web search. Here we are adding a layer of web search to find the most relevant and latest answers. And if in all the documents are relevant and they answer the question, we just then provide generate the answer. Next is the adaptive RAG, which is a more complicated one, where we do a query analysis. If it's related to the index, unrelated to index, and optional. If it's unrelated to index, we do a web search, generate node, and give the answer. If it is related to index, then we rewrite the question, and then we first retrieve, grade it. If it's not relevant, we rewrite the question and then send it back again, and then we send it back to the generate node, and then over at the generate node we see if any of the all the chunks are relevant or not, and again and check for hallucinations, and finally we send it to the answer. Now I've used multiple uh, metrics to track this. One is the faithfulness, where it measures whether the generated response contains only information that can be derived from retrieved documents. It detects hallucinations and unsupported statement. Similarly, context precision and then context recall. All the information for that is added here with the formulas, and also answer relevancy and answer correctness. Uh, and then we also do a combined raga score where we are just averaging it so that we can see a single metric in the end. Now we do our data preparation where we are chunking and then embedding it, storing it, and then we are doing a vector store setup. I'm using ChromaDB for the vector store, and then I'm indexing it and upserting all of it. Now first I performed the analysis, on a simple rag, then the CRAG, and then finally the adaptive rag. This is all the code for that, and then I'm setting up the evaluation framework and setting up all the metrics I need, and then I'm calculating all the scores. In the end, I will be visualizing the metrics. Yep, we can see that our in terms of faithfulness, uh, our corrective rag was more appropriate. Then in terms of context precision, also corrective RAG. And in terms of context recall, we can see a simple RAG. Here the problem is like why we see such close numbers or like a small difference here and there is because of our the data set we choose in this analysis is small, the one I've done for the crash course. But in the worked example, I've chosen very long data sets, I mean like very huge data sets. And similarly for faithfulness and heat maps and overall, like we can track the overall score, which is our corrective RAG performed way better than the other two. We can see the numbers are somewhat like close by, but in our worked examples, we'll have a better understanding. In the worked examples, I've chosen two data sets. One is amnesty and Hugging Face data set. The code on top explains everything. I'm just like going to show the analysis which we performed and comparison. So in terms of, we can see for all of it, either the CRAG or adaptive RAG performs better. Similarly, we can see this for both for all the data sets. And in the end, we can see our adaptive RAG is actually more performant than the others. Thank you.